In this video, I'm going to explain about how to write program for I/O ports of this microcontroller ATmega 2560. In the earlier video, I explained in detail how to access these I/O ports of ATmega microcontroller. If you have not watched that, please go and watch that first. The video link will be coming in I button. Just go and watch that. It will be helpful to understand this video. Let's start writing this program, which will demonstrate how to use I/O ports. Demo for input. I'll be showing first about the input, then we'll write program for the output. So for input, what we need to firstly configure for pull-up registers. So how can we do that? Using port register we can do that. Let's do one thing. Enable pull-up register for 0th pin of port B. Enable pull-up and keep the pull-up disabled for pin 1 of port B. Disable pull-up. So first let's do one thing. Port B, what we have to clear? Bit 0 and bit 1. So let's clear bit 0 and bit 1. To clear bit 0, what we have to do? 0th bit we have to clear and first bit we have to clear. So I've cleared it. And after clearing 0th and first bit, you are disabling pull-up for both. But we have to enable for bit 0. So let's enable it. Port B, enable for which bit? 0th bit. So now you have enabled pull-up for pin 0 of port B. So this is done. So after enabling pull-up, we have to configure for what? Input. Where we have to configure? In data direction register. So we are using port B, so data direction register for port B. So in port B, what we have to do? We have to clear which bit? Port 0 and port B. Port 0 and port we have to clear 0th and first bit. So same thing I am doing copy paste. Bit 0 and bit 1 we are clearing up in data direction register so that it will be configured for input. So now we have done the configuration, and for reading what we have to do? We have to simply read the which register? We have to read the pin register of which port? B port. So pin B we have to read. Let's take a variable called read port, make it 0. Read port equals to which one we have to read? We have to read pin B. So this register we read, and after reading just check you had enabled pin 0 of port B, right? So just check here if read port do AND operation, bit 0 should be enabled, right? Because it's pulled up, so you will get high status over here. So this bit should be enabled here. So if you are getting so, then you are good. Print ln high status pb0 high status received as expected, right? Otherwise give error something else. Serial.println pb0 low status received, which was not expected, right? This one was not expected. Similarly check for port B pin 1. This was for pin 0 and this is for pin 1. So here we are expecting low, right? Because it was not pulled up. This one was not pulled up, so we are expecting low status over there. So if we are getting high status, then this is a case of not expected, which was not expected, and we were expecting low. So low were expected. Let me just compile this code. It gave some error. See, this is correct, this is correct. Okay, I missed semicolon. Okay, let me compile it again. Yeah, compilation is successful. Let me connect my board. So I'm connecting. It is connected now. You can see the USB symbol here. This is connected. Let me download this code. Download had successful now. Let's open serial monitor, and this baud rate was 115200. It's matching. You got the print also. So demo of input pb0 high status received as expected pb0. Okay, here there is a issue, so let me change this pb1. Let me download it once again. Just opening again this serial monitor. Okay, so for pb0 high status received, and in the second one also we received the high status, right? So why it has come like this? If you remember from previous video, there is a concept called synchronization. So there is a latch for synchronization which takes one extra clock to synchronize the input to the output register. So for that we have to give a no operation over here, right? Before reading it we have to give a no operation. So let's give that ASM no operation, and let me download this. Download as successful now. Let's open again. Now you see, you got that, right? High status received as expected and low status received as expected. But earlier what you are getting? You are getting the wrong pin status, high at both the pins. So because that latch, synchronized latch, takes extra time to sync the pin status to this pin register. So because of that this error was coming, and the time when we give a extra delay, we just delayed by 1 clock. So after doing this we are getting the correct pin status. So that's why we must insert this propagation time delay. So this was about how can we read the pin status. Let's do for output also. So demo for input and output. And for output, let me select PB7. So this is connected to LED present on board. So we have to make this as output, and let's make it high by default. So I'm making it high. So I configured it, and data direction register should be DDRB. Do OR operation for which bit? 7th bit, right? So this is done. So we have configured for output. Configure for output which bit? 7th bit. So PB7. So this is done. And after doing this, if I simply download this code, the LED should glow or not, because we have configured as output, and default status I configured here as high. So this pin will be pin 7 of port B will be high and LED will be glowing. So let me download this code. Okay, there is an issue. Okay, this string was not proper. Okay, now download has successful, and you can see now this LED is glowing, the yellow LED. And now let us change this. Let us clear this pin. By default it will be cleared, so I am clearing it, 7th bit. So if I download it, yeah, you can see now the LED has turned off, right? Let us now blink this LED. So in the loop, glow the LED. After that give some delay of let's say 1 second, and turn off LED, and again give the delay of 1 second. So it will be blinking now. To glow, what we have to do? Port B 7th bit we have to enable. So 7th bit I have enabled, and to turn off, what we have to do? We have to clear that bit. So clearing, what we have to do? We have to do AND operation for 7th bit. So I have cleared that bit. Port B, yeah, this is correct. So now if I download this code, the LED on the board should blink. See here, this yellow LED near this USB connection, it is blinking with 1 second delay. This is working, right? Now let's do same thing with the help of pin register. With this register also, this pin register that we had used to read the port, with this one we can toggle the LED. Let's do that. I'm just commenting this line and this line, giving let's say 3 second delay. So for 3 second LED should be off, and 3 second LED should be on. And let me comment this also, and toggle LED. So for that, what we have to do? Pin B, and which bit we have to write? 7th bit. So if we simply write this, so it will toggle the pin status. So now 7th pin of port B will be toggling for every 3 seconds. Let me download this code. Yeah, download has successful, and see now. You can see LED is glowing. 1, 1, 2, 3. It's off. 1, 2, 3. So off. Again it's on. Yeah. So this is working fine now. So by doing this, we can easily access our IO ports. And by default, Arduino has ready-made APIs. With that, you can configure your pin and you can perform write read. So for that, let me comment this. I have commented now. So let's configure that bit as output. For that, we have ready-made API pin mode. So using pin mode, you have to just select the pin number. Pin number is 13 for LED, and you have to just make this as output. And here, if you call digital write, digital write. So with this you can set as high or low. So let me set as high, and let's give a 1 second delay of 1 second. Then again let's do digital read 13-bit as low, delay of again 1 second. So it will again blink the LED. Okay, there is the issue. Okay, this has to be commented. This here is read. This should not be read, this should be write. Output, this was the issue. Output, yeah, this has downloaded now, and if you see, the LED is blinking with 1 second delay. See, this is blinking with 1 second delay again. So with ready-made APIs also you can use, and for read you have to simply issue digital read. So with that you will get the status for that digital read if you issue simply, and pin number you have to mention. As you can see here, pin number we have to mention. So with this you can get the status, either 0 or 1 you will get it here. So like that you can do. I'm not doing right now, you can explore it. So with this explanation you would have got the overall idea how to use the IO ports of a microcontroller. Let me know in the comment box if you have any doubt for this, and anything you want extra, let me know in the comment box. I'll try to answer. Thank you so much for watching this video. Let's explore and continue different thing in next video. Stay tuned, and I'll see you soon.